So in homework 3.1 to 3.2, it's asking you to find a sample space. Let's say you were to flip a coin 4 times. This is a fair coin, so you have a half probability of heads, half probability of tails. So I drew out this tree diagram of the sample space. You start here seeing we pick a coin, and on our first flip, we have a choice of either a possible outcome of heads or tails. Since each one of those are equally likely, each one is zero point 0.5, so I'm just putting those probabilities on the outcomes. For the second flip, you flip the coin again, you have another two possible outcomes. But again, that's two possible outcomes for each of the initial outcomes. So, for example, if you had rolled the heads the first time, then you have a 50-50 chance to get in the heads or tails on the second flip. So if you were looking for heads and heads, you can multiply the two together. 0.5 times 0.5, which is 0.25 or 1/4. You can also see that there are 4 things in the sample space of 2 flips. So going to 3 flips, again, each one of those outcomes, you have another flip, so you have another 2 possible outcomes. So now you're up to 8 possible outcomes. And again, each one of these are equally likely. And if you were to multiply down the branches, you're looking at approximately 1/8. So for the 4 flips, now you have another 2 options. So you have 2 outcomes for each for the 4 flips, or 2 times 2 times 2 times 2, which is 16. So here's the example of the sample space. These are all the possible branches. As you can see, there are 16, and each one is equally likely. So to get any one of these, you can just follow the trail. Let me see if I can highlight one here. Let's say we did, I say the first time we got a heads, and then we got a tails, then we got a heads, and then heads again. Okay, so that would give us our sample space of heads, tails, heads, heads, which again is 1 out of the possible 16 outcomes, so the probability is 1/16. Also note, if you have 16 different branches you could take, and here is all the possible combinations, each one of those being equally likely. And again, since the probability, if you take all the items in the sample space, have to equal 1, and of course here, of course, they do. So I hope you found that helpful.